Hello everybody and welcome back to Advanced Functions. Today we'll be talking about Chapter 2.3, which is a direct continuation of Chapter 2.1 and 2.2. For that reason, this lesson will be rather short, probably extremely short compared to my other ones. Okay, so 2.3 is just focusing on polynomial equations and how to solve them. This chapter is essentially full of word problems, and those two involve either simple factoring that you already learned or applying the factor theorem. So let's get started. Solving polynomial equations. In this chapter, as I said, we'll be focusing on chapter 2.1 and 2.2 combined to solve real-world problems. They might not be the real-world problems you're thinking about, but they definitely do happen in real life, so that's what this chapter is for. So the key here is to apply all the knowledge you gained from factoring and the new learned factor theorem to solve these problems. You will be likely asked to find the roots of the polynomial equations, which is again the value of x for which f of x is equal to 0. Also, for some questions in the book, the equations cannot be factored. I don't know if they meant to do that, but if you can't factor the equation, then you have to use a graphing calculator. On your tests, I don't think you will be getting any questions that can't be factored, because that will just require you to use technology, which doesn't make sense to me in a classroom setting, but I don't know, maybe with online school it'll be different. So when it comes to world problems, or word problems, here's some of my personal tips that I do to finish things much quicker and be more thorough with my questions. Usually, all word problems that are rather long have a really long-winded start. Like they start telling you that Jessica went into a park with her dog and they were traveling to see the nature. Like again, that information is so useless. They're just trying to make you waste time. So really what you should be paying attention to is any numbers that you see in the equations or in the word problems. Those numbers are most likely going to be part of either the restraints you're given or the actual equation that you have to use. So pay close attention to that. Also, the last sentence is usually where the question is at, or the last sentence will give you the restraints or the units you should be using, but that's like the key info. Always just look for that question mark and those numbers, and it'll help you save a lot more time. Okay, well, let's do some examples. These are rather simple. You have to just factor them. Again, I could do an example of these, but if you're paying attention to my lessons, I already stated how many times these are super repetitive. So again, this is just another way for you to practice. And for the word problem, as you can see, it's saying that the distance is measured in d, and that is meaning in kilometers. That is completely useless because we already know it's measured in kilometers by the last unit they're giving us in the last sentence. All we have to look at here is see that d of t, which is probably distance of time, is equals to this equation where t is constrained by that. How long does it take for the plane to fly that long? That is it. That's all you need to know. Nothing else over here on the top is needed because you know you're given t, that's time, hours, because how else would a plane fly? In minutes? I don't think that makes sense. Yeah, I will do question D for you in just a couple of moments, but again, these three, I think you could do them by yourself. Plus, D requires you to factor in the first place, so I don't see a problem here. Yeah, this is the homework. Again, just a lot of factoring and a lot of word problems, but it's nothing big, and I believe that if you have been doing the questions from 2.1 and 2.2, you should be a breeze. The reason why there's a lot of them is again for practice. You don't have to do them all, but it will give you a really good basis for your test. So now let's do this question here. Okay, so let's do the question. The distance t in kilometers traveled by a plane after 2 hours can be represented by the following equation, where t has to be between 0 and 15. How long does the plane take to fly 1,260 kilometers? Okay, so that is distance. And distance to us is given in terms of time. Therefore, we could rewrite this question as the following. 1,260 kilometers is equals to 3x to the power of 3. Also, I've noticed just now there should be t. See, this question wasn't perfect. If you noticed that, then congratulations. So let's write the t plus 27t squared plus 366t. Okay, we have an equation. Let's isolate. So we have 0 is equals to negative 3t to the power 3 plus 27t squared plus 3600t minus 1260. Okay, so immediately we see that we could factor 3 out. The quickest way to find if something's factorable by 3 or is possible to divide by 3 is just to add all of the integers together. So 3 is definitely divided by 3, 2 plus 7 is 9, 9 is divisible by 3, 3 plus 6 plus 6, that is 15, 15 is divisible by 3, and 1 plus 2 plus 6 plus 0 is 9, 9 is divisible by 3, therefore everything could be divisible by 3. So we actually could remove a negative 3 out of it, because why not? So we get negative 3 times t minus 9t to the power of 2 minus 122t plus 1260. Give me a second. I'm just gonna make sure I get this right. 420. That's a great number. We like that. Okay, so that's our equation now. From what we could do here, we know that if we multiply 0 by negative 3, it still gives us a 0. So honestly, we're not caring about the negative 3. All we care is about this portion over here. So what we're trying to factor is t to the power of 3 minus 9t squared minus 122t plus 420. So let's say let p of x or p of t equal to that. From here, we have to apply the factor theorem to find for which values of t will p of t equal to 0. So we can see already that we have a 1 over here and 420, so we need to find the factors of 420. So b could equal to plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5, plus minus, what else? 420, that's a big number. What you could do is always stop in the midway point. So as soon as we reach 210, you know, that's not the middle, so we have to keep going backwards. So 420 divided by 6 is 70. Is it divided by 7? Yes. 7 plus divided by 8. What do you think? It's not divided by 8. It's divided by 10. 21 is divisible by. Anything else? 21. So it should be divisible by 20, which I forgot. And then we just do the backwards version of that, and so on and so forth. So let's quickly do that. You don't have to write all of these down, because essentially it's going to take you a lot of time, but you just need to find a t value using the theorems you already learned. 42, I think it was 60, 70, then 5, 84, 105, 3, 140, 2, 210, and then again 420. That is all the numbers we should have. Now let's find out for which of these p of t actually gives us a 0. We know it's not going to be 1 or 2 because these are way too big over here for them to equal to 0. So I would begin at probably around 4. So let's try 4. 4 to the power. Let's try it here. Sorry, I'm just gonna write it down on my calculator so we don't have to try to do this all over again or waste more time. Plus 420. Okay, so what do we have? 4 would give us minus 9. Yeah, 4 is not. 4 doesn't give us it. Doesn't equal 0. Negative 4 doesn't equal 0. That seems to be a little bit too big, so let's go back down to 3. P of 3 is equals to is equals to 0. Therefore, 3 is a t value. So t minus 3 is a factor of p of t. That is great. So if we now divide p of t by t minus 3, since we have t minus 3 as a simple binomial with no a value, we could use synthetic division. So let's do that. 3, and now we write down all the coefficients, negative 9, negative 122, 420, perfect. Our answer line, carried down, 3, negative 6, negative 18, negative 140, this is negative 420, 0. Okay, so we have our new value. Gonna actually just write it over here. So we have let p1 of t equal to our new value, which is x squared minus 6 t squared, sorry, minus 6t minus 140. Can this number be factored? It has to multiply to 140 and then also add up to negative 6. Let's quickly check. We could use the quadratic formula for that. Okay, so it can't be factored, so again we have to use the quadratic formula. The quadratic formula is equals to negative b plus minus square root of b squared minus 4ac divided by 2a. Right? So what we should do is plug in the numbers. So we have 6 plus minus square root of 36 minus 4 times 1 times negative 140 divided by 2 times 1. You should say t is equals to, over here, since we're trying to solve it, t is equals to 6. Okay, these numbers turn out to be negative 9.207 and the other one is 15.207. So these three numbers, 3, negative 9, and 15, are the t values for which the plane flies 1,260 kilometers. However, now we have to look at the restrictions. The restrictions for t is that it has to be from 0 to 15. This is outside the bounds, and this is also outside the bounds because we can't have negative time. Therefore, our final answer would be that it takes 3 hours for the plane to fly. 3 hours. This work over here is necessary since we have to prove that no other values will satisfy it. But again, it might seem a little bit excessive, but you have to do it. Okay, again, this is the homework for today. What I would like to do is actually quickly go over what those questions are, rather than just solve them. I'll give you the strategies to solve them, but you can do it yourself. So let's look at them now. Okay, so for the homework, I've assigned 4ac. Determine the x-intercepts of the graph of each polynomial function. So we have y is equals to that, p of x, and g of x. The only interesting ones I would say is e, because we have something x to the power 4 minus 16. What we need to realize here is that it looks to be a difference of squares, since we have x to the power 4, which is the square of x to the power 2, and 16 is the square of 4. So you would do that, and you would get x squared minus 4, x squared plus 4, then x squared minus 4 is again a difference of squares. So factor that further, and you get your new equation. From there, you just need to use the quadratic formula for one of the intercepts, if they exist, just to make sure, and that will give you the numbers, or the x-intercepts of the graph. Everything else just requires you to do basic factoring. The other question I assigned was 5, so let's look at that one. Is each statement true or false? If the statement is false, we reward it to make it true. So A is, if the graph of a quartic function has 2 x-intercepts, then the corresponding quartic function has 4 real roots. Okay, well, what it's saying is that since it has 2 x-intercepts, it shouldn't have 4 real roots, because the roots of the function are the values at which the graph, or the f of x, is equals to 0. So if we have 4 real roots, then the equation should have 4 x-intercepts. B, all the roots of a polynomial equation correspond to the x-intercepts of the graph of the corresponding polynomial function. That is true. A polynomial equation of degree 3 must have at least one real root. Okay, so of degree 3 means that it would pass through the x axis at least once, so that is true. So I guess it is correct. D, all polynomial equations can be solved algebraically. No, that is not true. If the polynomial at hand is not factorable, then you cannot use algebra to solve it. You will see that in actually chapter 2.5, which requires you to use graphing to solve an equation. Now for E. All polynomial equations can be solved graphically. Yes, that is absolutely true. If you can graph it using some graphing software like a graphing calculator or Desmos, then it could easily be solved. Okay, so what else did I assign? I assigned 7, B, and D. So by factoring, you got this. Just apply the factor theorem and you are good. We have 10 now. The width of the square base storage tank is 3 meters less than its height. The tank has a capacity of 20 meters cubed. If the dimensions are integer values in meters, where are they? Okay, so what we have here is height and then the width. What we know for a fact is that we could let height be equal to h, or let it be h, and then width has to be h minus 3, since that's the width. The tank has a capacity of 20 meters squared, cubed. So what we actually have for our equation is h times h minus 3 squared, and that is equals to 20. Now we're just solving for h, and now we're solving for w. That is about it for that question. Then we have 12. So for 12, what we get is actually the passenger section of the train has the width. Oh, sorry, no, that's not 12. Is it possible for a polynomial equation to have exactly one irrational root? Of course it can be. The reason for that is, again, if you look, for example, at question 6, what we see is that, was it question 6? No, question 5. Let's say you have cubic function, right? And you perform some transformations on it, like we learned from last class. What you could end up happening is you form an irrational number. So we learned that you could have cubic functions of the form like x to the power 3 plus 1, or actually not plus 1, plus 2. For that to work, what you need to do is change it from x to the power 3 plus 2 to x to the power 3 is equals to negative 2, and then you have to find the cube root of negative 2, which is an irrational number. That's the only root you could have, but it is also irrational. So this is a perfect example of that. Now I've also assigned 13. Is it possible for a polynomial equation to have exactly one non-real root? Okay, well, let's think. For it to have one non-real root would mean for it to have an imaginary number as its solution. You might have learned a little bit about imaginary numbers in grade 11, but again, it became something out of our curriculum a few years back, so it might be something you don't know. So the problem with imaginary numbers is the following. Let's say you're trying to take the square root of negative 1, right? What you actually have is the square root of 1 and the square root of I. The square root of 1, we know, is plus minus 1. So from there on, what we get is 2 not real roots. And that is true for all imaginary numbers. So for this question, the answer would actually be no. It's not possible, because as soon as you take the root of an imaginary number or of a negative number, you will have 2 non-real roots. Okay, so question 15 is next. A steel beam is supported by 2 vertical walls. When a 100 kilogram weight is placed on the beam, x meters from one end, and the vertical deflection in d meters can be calculated using the following formula. Again, all we had to know here was 100 kilograms and the equation, how far from the end of the beam should the weight be placed for a deflection of 0. So let this equal to 0, and then you solve for x. It's nothing difficult. Again, it is super simple and super familiar with what we have learned already. The one thing you could notice, for example, is that over here we have x to the power 4, x, 3, x. You could factor out the x to make your life easier. But if you don't like your life being easier, then you could use it anyway. But again, it's just simple factoring or applying the factor theorem and finding for what value of x does d of x equal to 0. And that is around it. Lastly, I've assigned 18, which is determine the value of k such that negative 2 is one of the roots of the equations. Okay, so if it's negative 2 is a root, what that would imply is that when x is equals to negative 2, the full function is equals to 0. So we need to just transform this function or rearrange it to have it equal to 0 on one side. Then we would substitute negative 2 in for all the x values, and then we would solve for k. That is all you have to do. You just need to know how to manipulate your equations. All of these questions, again, are super simple once you get theory down behind it. And if you did questions from 2.1 and 2.2, you should be more than fine. If you have any problems, please let me know. I'll be more than happy to help with all the questions here. But I believe you got this. So I will see you in the next video. And that's about it. Again, thank you so much for listening to today's presentation. It was a little bit shorter because we're just simply using knowledges we already gained. I don't feel like it's necessary for me to go over all of the questions. nor do I think it's beneficial for you. But if you feel like you need me to do them, always feel free to email me and I will send you a detailed explanation for each of the questions. I hope you have a wonderful day and thank you for listening.